Alright, so for project 4 in lesson 16, we're at the Creating Dilations tab, and we're going to go through this. Question 1. Assume that the following figure shows a part of a city plan. Point A represents a museum, and segment BC, segment DE, segment FG, segment HK, segment LM represents streets. Furthermore, segment BC is parallel to segment FG, is parallel to segment LM. If a street is drawn by dilating segment FG about center A with a scale factor greater than 1, which of the segments could be that street and why? Okay, so this is a critical thinking connecting with what happens to a segment when it's multiplied by a scale factor greater than 1. And it goes back to your vocabulary definitions of enlargement or a reduction. So if we look at FG right here, this segment is dilated by this point A with a scale factor greater than 1. So that means I took this segment and I either doubled it, tripled it, quadrupled it, multiplied it by 5, made it bigger than that, or it could have been 1.5 times bigger. Anytime it's greater than 1, we have an enlargement, which means it becomes bigger. The segment is bigger. So if I look at this and I'm looking to the left of FG, these segments are smaller, so that means it was a reduction. And if I look at to the right, these segments are bigger, so that means it was an enlargement, which means the scale factor is greater than 1. So, which segments could it be? It could be, let's look at these options. LM, okay, LM because LM is parallel to FG, and the scale factor is greater than 1. That is correct when you have an enlargement. FG because FG is parallel to itself and the scale factor is greater than 1. Not true. It would equal 1 because it's itself, and 1 time multiplying something by 1 does not change that value. For example, 1 times 2 equals 2. So that one's not true. Alright, BC because segment BC is parallel to FG and the scale factor is greater than 1. Well, if we look at BC, it is parallel, but the scale factor is not greater than 1 because it's smaller than FG, so it was reduced. Segment DE because segment FG is parallel to segment DE and the scale factor is greater than 1. So again, you look at DE, it is smaller than segment FG, so it could not be having a scale factor greater than 1, and it's also not parallel, so that means it was dilated differently than point FG would be dilated. So the solution for this one would be LM, segment LM, because it's greater than it and it is parallel to FG. Alright, refer to question 1 to help you answer this question. If FG equals 3/4 miles and the length of LM is equal to 1.5 miles, and the scale factor for the dilation is blank. So this is how I think of it. If you take the distance of FG and you multiply it by your scale factor, that has to give you the length of LM. So we know by substitution that FG was 3/4 of a mile. And I'm actually going to change this to a decimal because the length of LM is in decimal form. So I know that 3/4 is also represented by 0.75. So FG by substitution is 0.75 times K, our scale factor, and that's going to equal the length of LM, which is 1.5. So then, since 0.75 is multiplying to our scale factor, we would divide by 0.75, which is our division property of equality. Divide by 0.75. And 0.75 divided by 0.75 is 1. So we now have 1 times K equals 1.5 divided by 0.75. I'm just going to type that as 1.5 divided by 0.75. That equals 2. So 1K in math, it was assumed that 1 times K, since it doesn't change its value, we could just write it as K equals 2. So on this, the scale factor is 2. Alright, refer to question 1 to help you answer this question. A straight is drawn by dilating segment FG about center A with a scale factor greater than 0 but less than 1. Is this an enlargement or a reduction? Okay, so give me, if I cannot think of the definition of an enlargement or a reduction, I'm going to think, well, what is a number between 0 and less than 1? And I can think of 1/2. That's between 0 and 1. So if I look at FG, this length, and I were to multiply that length, and we'll just use the length that it gave us in question 2, 3/4 miles, or 0.75. If I took 0.75 and I multiplied it by 1/2, 1 divided by 2, that is a number that's greater than 0 and less than 1. It equals 0.375. So then I'm going to ask myself, well, is 0.375 larger, enlargement, or smaller, a reduction, reduce? That's where, so reduce, reduction means smaller. Enlargement, larger, means bigger. So is 0.375 larger or smaller than 0.75? And it is smaller. So I could think my way through this question if I didn't know the definition of an enlargement or a reduction. And that's an example of how to do it. I would write in your notes the definition of an enlargement and a definition of a reduction. So this one is a reduction, which is having a scale factor greater than 0 but less than 1. And question 4, refer to the previous question. What could be the street described in the previous question? So what line was reduced by a dilation of FG? So it has to be parallel. And this reminds me of when you put a rubber band on your finger and you stretch it out. That's an enlargement of that rubber band. And when you let it shrink from your original size, that would be a reduction. And it has to be parallel to it. So BC could be the segment that was described because it's parallel to FG and it is smaller than it. So I'm looking for BC because BC is parallel to segment FG and the scale factor is greater than 0 but less than 1. Alright, question 5. Find some examples from real life where dilations are helpful in modeling context. Post your findings and explain how this concept is used. So, to model this, I would type in real life examples of dilations. And it comes up with images, and so I will let you decipher through and find which one suits you. And I don't want a picture that's like this. That's just a diagram. That's not something in real life. This looks like a great real life example. And I will leave it up to you, or these look like great real life examples. You could also click possibly on one of these other websites that I pulled up and look for real world examples that have been presented there. So there's a helpful hint for what to Google in order to answer question 5. And then I will be looking for explaining how a dilation was used in that picture. So you need to be able to explain why it is a dilation. And I'm looking for proper grammar and sentences. I want at least 5 sentences. So on this.